Hello everyone, welcome to our today lecture. In our today lecture, we will be seeing that how to apply quantile regression in EViews by using time series data. So basically, first of all, we will discuss that what is quantile regression, and then we will be seeing what are its advantages, and then we will be seeing that when to apply quantile regression. And after that, we will be applying quantile regression analysis to time series data, and then one by one we will interpret all the results. So basically the quantile regression, it was introduced in 1978 by Roger and Gilbert. So quantile regression is a statistical technique that models the conditional quantiles, e.g. 25th percentile, median, and 75th percentile of a dependent variable as a function of independent variable rather than just the conditional mean like ordinary least square. So in case of ordinary least square or the OLS, we have simple results, and while in case of quantile regression we have multiple results, like we can obtain result in term of three model like 25th percentile, 75th percentile, and the median percentile, that is 50th percentile. So in case of OLS we estimate one single regression, but in case of quantile regression we can estimate as much as quantile that we want to regress. In quantile regression, you estimate multiple regression lines, one for each quantile, and its value is between 0 and 1 by minimizing the weightage sum of absolute deviation. Second thing is that what are the advantages of quantile over the simple OLS. So first advantage is it's robust to outliers, minimizes absolute rather than the squared errors. So the second advantage is does not assume homoscedasticity. Is if you have the issue of heteroscedasticity in your data set, then in that case it is quantile regression will give you the best result as compared to the OLS. So basically when there is variable variance or there is an issue of heteroscedasticity, so one of the assumption of OLS is violated. So in that case you cannot apply OLS. But if you have heterogeneity issue in your data set, then you can still apply quantile regression. So the third is reveals heterogeneous effect. Variable may boost high growth economic but have no or specific effect in low growth one. So in term of quantile regression, you can check both the low effect and the higher effect while applying quantile regression. The last one is allow you to see the full shape of the conditional distribution. And the next thing is when to apply quantile regression. You can apply quantile regression when you suspect or want to test the effect of x on y, like the independent variable on dependent variable. It differs across the distribution of yg. For example, stronger effect at the upper tail of GDP growth, weaker or negative at the lower tail. Second thing is that if your data set is skewed as heavy tails outlier, and if your data set have outlier in your data set, then in that scenario quantile regression will be the best option for obtaining the result. The third option when you want to apply quantile regression is that if you care about extreme or specific part of the distribution, what drives very low growth periods, what help very high growth. And the next thing is you want to more complete picture than the average. So as I mentioned earlier that in case of OLS it gives that the only average values, but in case of the quantile regression it gives us multiple regression analysis like 25th percentile, median, and the 75th percentile. So the last thing is policy analysis, inequality studies, risk management. If your data set is consist of any of those variables or any of those models, then it is suitable to apply the quantile regression. So this is all about the theoretical aspect of the quantile regression. Now we will go to the EViews, and then we will be applying the quantile regression, and then we will be discussing the interpretation of quantile regression with comparing with the OLS. So now here I have opened my EViews. So first thing is that we have to copy our data set from the Excel file. So now I have copied my data cell. Now go again back to EViews, click on file, then new work file, Here you have to tell the start and end date of your data set, and then you have to mention that what is the frequency of your data set. Either it is yearly, monthly, quarterly, bi-monthly, quarterly. So as my data set is annually, so I am going with this option of annually, and from these options you have to select either your data is time series panel or balance panel. So as for the time being, we are taking the time series data, so we are going with this option, dated regular frequency. Then click on OK. So after that, go to quick, then click on empty group, and here you have to copy your paste all of your data set. So now you can see that our data is now present here in EViews. So you can also use the command option to write your dependent and independent variable. And the second thing is that if you want to go with the manual option, then select with by starting the dependent variable you are first. So in this scenario, we will be taking and assuming that GDPG is our dependent variable, FDI and HDI are our independent variable. Then right click, open as equation, and then simply first of all we will be having the result of OLS. Then click on OK. So now here you can see that it has given us the result of simple OLS model. So as I have already copied this result into my OLS result. So now here you can see that our dependent variable is GDP, method is LS, and the sample size is from 1996 to 2019. Total observation are 24. And as you can see that our first independent variable is FTI, and its coefficient sign is positive, so it means that there is a positive relationship between FDI and GDP. And second independent variable is HDI, its coefficient is also positive, and it means that it is showing a positive relationship with GDPG. So now let's explain its interpretation. So FDI sign is 0.08. So on average, 1 unit increase in FDI is associated with an tiny 0.08% or unit change in increase in GDP. The effect is positive but extremely small and statistically insignificant. So for the significance or insignificance, we have to look at the p-value. If the p-value is less than 0.05, then it means that our variable is significant. So in this scenario, both the FDI and HDI value is greater than 0.05. So in the so that means in case of OLS result, FDI and HDI both are showing positive effect, but they are not statistically significant as their p-value is greater than 0.05. And second thing is that constant. So constant means the intercept, this one C. So it shows the average value of the dependent variable when all other variables are 0. It is also insignificant. And the R square value is 0.007, that is very low. It means that both of the variables are only explaining 0.8%. So it means that the variation in GDPG is because of FDI and HDI is only 0.8%. That is because our FDI and HDI both variables are insignificant. So that's why R square value is very low. So now let's apply quantile regression on the similar data set. So we have to go to the estimate and then go to method, and here you can see that there is an option of quantile regression. So click on this quantile regression, and by default it is with selected with 0.5 or the median. So we have to select it by first 0.25. So now here you can see that it has given us the results. So as I have copied all my result here already, so now go to here. So this is the result of quantile regression at 0.25 or lower tails or lower growth episodes. So again our dependent variable is GDPG, and sample size is the same, 1996 to 2019, included observation is 24. So now you can see that when we applied the lower tails, FDI is become negative. So this is the first advantage, that you can see that when you apply 25th percentile, your results become positive to negative. So in this way you can see the better picture that OLS does not gives you. So in this scenario you can say that uh, in the lower picture FDI has a negative relationship with GDP. So FDI has a negative sign that at lower tails higher FDI is associated with even lower growth when the economy is already growing slowly. And HDI is showing the same sign as with the OLS. In case of OLS, HDI was positive, but in case of 25th percentile or the lower tail, HDI is also positive. But again, FDI and HDI both are showing insignificant result because their probability value is greater than 0.05. And again the R square is 0.03, which is very low. So why it is very low? Because FDA and HDA, our both independent variables, are insignificant. So when your variables are insignificant, then it is obvious that your R square value will be very low. So now go again to EViews, and now we will be applying 50th or the median percentile, and we will see that what will be changed in the coefficient signs and R square signs. So now as you can see that we have the result for the median of the 50th percentile, and now we will try to interpret the results. So now here you can see that we have the result of 50th median, and our dependent variable is GDPG, and sample size is the same 1996 to 2019. A number of observations are 24, and as you can see that when we change from 25th percentile to 50th percentile, you can see that the FDI sign changes from negative to positive, and when you look at the HDI coefficient value, it is also positive, but now it is showing a larger effect. Its coefficient value increases from 2 to 10. But again, when you look at for the significance, the probability value is greater than 0.05, which means that they both are still insignificant. So FDI turns mildly positive as it was negative in case of 25th percentile, and HDI now has a larger positive effect. So higher human development appears to be associated with lower median growth. So and R square is still very much low. Now we will be applying the 75th percentile, and we will be comparing the result again. So go to estimate, and now select 75 here, 0.75. So now you can see that we have the result for 0.7575. So now I have already copied this my result, and we will go to PowerPoint, and we will be explaining the result here. So now you can see that FDI is still positive and its value is 0.32, and in case of 50th percentile its value is 0.17, and in case of 75th percentile its value is 0.32, which means that it is a stronger positive coefficient. And so it means at the lower tail or in the middle tail, FDI has a smaller effect, but in case of upper tails, FDI has the strongest positive effect, and we can conclude it by looking at its coefficient value. Again, the HDI has a strongly positive effect again, and still no statistical significance. And so when we applied OLS, 25th percentile, 50th percentile, and 75th percentile, all of these results tell us that our probability value is insignificant. Why? Because our probability values are greater than 0.05, which means that they are statistically insignificant. And R square value always remain very much low. Why? Because our both the variables are insignificant. So when your variables are insignificant, it is obvious that R square will be very much low. So this is how you can obtain and interpret the results of OLS, 25th percentile, 50th percentile, and the 75th percentile. Now I have already made a table where we want to combine and we want to compare the results of all of these. So the first column is showing the OLS result. The second column is showing the quantile regression of 0.25. The third column is showing the median result of quantile regression, and the fourth column or the last column is showing the quantile regression result of 75th percentile. So when you look at the FDI coefficient when we applied the simple OLS, so you can see that FDI value is 0.08, 0.08, and you see that uh, in case of 25th percentile it will become negative. So we can conclude that in the lower tail FDI is showing negative effect, but in the middle and upper tail it is showing a positive effect. And similarly HDI value is positive both in simple OLS and 25th percentile, but it will become negative in the median or the 50th percentile, and again it will become positive on the upper tail or the 75th percentile. And when we talk about the constant is positive in OLS, simple OLS and the 25th percentile, but it will become negative in the median, and again it will become positive at the 75th percentile. So this is how you can compare. So FDI negative is low growth period, positive in increasing and in higher growth period. HDI positive at tails, strongly negative at the median, but all insignificant. As we discussed in our previous slides, that probability value in all of these cases is greater than 0.05, which indicating that our all variables are insignificant. So now let's talk about the conclusion and policy recommendation. As you can see that our data set is very small, so within only 24 observation from 1996 to 2019, both the OLS and quantile regression shows no statistically significant relationship because of the unavailability of the data set, and our data set is very small. So no relationship between FDA, HDA and GDP growth at any point of the distribution. The signs flip across. The signs mean the coefficient sign. At some point of time they are showing positive relationship, and at the some point of time they are showing the negative relationship, especially for HDI, which suggests possible heterogeneity, but the standard errors are very large and p values are all well above 0.10. The models have almost no explanatory power. The results are consistent with many small samples developing country studies. FTA and human development often show unstable or insignificant link to growth when other important control variables like trade openness, institution, inflation, etc. are missing. So it is basically telling us that we have to include these variables in our model to obtain the best results. So now talk about the policy implication. So in policy implication, the first one is for FDI. The pattern negative in bad time, positive in good time. So suggesting that FDI is more growth enhancing when the economy is already performing well. So what is the policy implication or the takeaway? So in case of bad time, FDI will not support you, but in case of good time, FDI increases your or double your economic growth. So policy focuses on attracting high quality, export oriented and technology incentive FDI rather than the volume alone. Avoid expecting FDI to rescue the economy during recession or low growth period. So it is basically telling us that if you expect that in your recession time FDI will support you, so in this data set you cannot conclude that in case of recession FDI will support your economy. Then for HDI, the flip from positive large negative then positive is in interviewing but unreliable with the sample size. Policy implication is that continue investing in health and education. HDI they are basically HDI components because the theoretically and long run evidence is very strong, even if this particular short sample does not detect a clear growth effect. As we mentioned earlier that our sample size is very small, so in that particular scenario we will not be having the ideal result. So this is how you can obtain the results of OLS and the quantile regression. And let me write here something for you for the significance. If the p value is less than 0.05, so that means your particular variable is showing significant results. But when your p-value or the probability value is greater than 0.05, so it's mean that your results are insignificant. So this is the main point that you want to understand in order to interpret the significance and the insignificance of your variable.